It's only because it's on the test. And I want to show you a little bit of how to go about calculating the probability of simple event, and then a compound event. Okay, this is a little bit different. So copy. This, you guys can write in your notebook. If you wrote a book, what would it be about? Okay, I'll skip that. All right, so an activity involving chance, such as rolling a cube, is called an experiment. Each repetition or observation of an experiment is a trial, and each result is an outcome. A set of one or more outcomes is an event. For example, rolling a 5, one outcome, can be an event, or rolling an even number, more than one outcome, can be an event. So you might I want you to copy this. Probability can be written as a percentage, as a fraction, as a decimal, right? So if it's impossible or it's never going to happen, obviously it's 0%. 0 is a fraction, 0 is a decimal. If it's for sure to happen, then it's 100% or 1, and then or 1.0. As likely as not, if you hear or see this times, it means 50%. Unlikely, I don't know, anywhere in between. Okay, it's unlikely, and likely, again, anywhere from 50 to 100. Okay? A coin. Now, a coin has two sides. Here in this country, we call this side heads, and the other side is called tails. So it's asking, writing possible and likely as not, likely or certain to describe each event. So a coin to land on tails. So if you throw this coin in the air and it lands on tails, what's the probability? What's the chance of it landing on tail? Well, there's on a coin, there's one tails, and how many possible outcomes can we have? We can have 2. So the probability, and this is how you write it, probability of tails is 1 over 2. What's the probability the spinner lands in green? So we're going to write P of green, write green inside parentheses. Well, there are 4 sections here. One of them is green out of 4. So the probability of landing on green is 1 over 4, 25%, or 0.25. Rolling a number greater than 7 on a number cube. This number cube is also called a die. All right. So one number cube is one die. If you have 2 or more, it's called a dice, because dice is plural of die. Okay. So now this is a die. That's called a die, right? Now a die has 6 sides, right? It has the 1, it has a 2, it has a 3, it has a 4, it has a 5, and it has a 6, right? It has 6 sides. So what's the probability of getting a number greater than 7? Well, there's no 7 here. There's only 6. In this die, there's only 6. So probability is 0. Right? 0% that you get a number greater than 7. Right? All right. So I don't know if I'll print this out, but you guys can use this. Right? You can translate. Well, maybe I'll print it out for you guys. You guys can practice a little bit. So you can translate this. What's the probability of rolling a number greater than 6 on a number cube? Okay, a number cube also is called a die. So what's the probability of rolling a number greater than 6? Impossible. It's impossible. Flipping a coin and getting heads. So if you throw a coin in the air and getting heads is 50%. So that would be C, right? Because this is, so unlikely, this is 100%. This is 0%. Sorry. This is 100%. This is 50%. Unlikely, it's like from 1 to 49%. This would be 51 to 99%. Drawing a red or blue marble from a bag of red and blue or from a bag of red marbles and blue marbles. So that is definitely certain. Spinning a number less than 3 on a spinner with 8 equal sections marked 1 through 8. So that would be unlikely. And rolling a number less than 6 on a number cube labeled 1 through 6. And that's going to be likely. Okay. And there's something we didn't talk about. So, again, to find the probability of an event, right? To find the probability of an event, it's P of whatever that event is over, so P of the event equals the number of times the event occurs over the total number of outcomes. Okay, so here is a cube, right? Numbers 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. 1, 2, 3, 4. Let me draw this a little bit better. 1, 2, 3, 4, 5 on the bottom, and 6, right? So there's a number cube. So what's the probability of getting a 6? So if you throw this in the air, what's the probability of getting a 6? Well, the probability of getting a 6 is 1 over 6. You don't have to worry about the fraction or the decimal. Well, actually, sorry. You don't have to write the decimal or the percent. You can just use your calculator if they ask you. But the probability of getting a 6 is 1 over 6. How many 6s do I have? I have 1 6 out of how many sides? How many possible different outcomes? 6. A penny, a coin, is tossing. What's the probability of getting heads? Well, the probability of the coin landing in heads, on heads, is half, or if you want to write it as a decimal, or 50%. Now, this says, what's the probability of getting a 2, 3, or 4 on a number cube? So if you have that cube again, right, what's the probability of getting? So if it goes on 2, it's okay. If it goes on 3, it's okay. And if it goes on 4, it's okay. So you have 3 chances out of 6. Right, so that's a 50% chance that that might happen. Find the probability of not rolling a 6 on a number cube. So not 6. I don't want the number 6. So I want 1, 2, 3, 4, 5, but not 6. So there's 5 chances out of 6. A bag contains 5 blue, 8 red, and 7 green marbles. So let's first of all find the total. 5 plus 8 plus 7 equals 20. So there's 20 in total. Right, so you're going to put your hand inside the bag and take one. What's the probability of getting not red? So P of not red. So not red. If you get red is okay. So if you get blue is okay. If you get green is okay. Right, so you have a 12 out of 20 chance. And you always simplify. Okay, this will be 3 out of 5. What's the probability of getting a green? Well, there's 7 greens, 7 out of 20. Yellow, how many yellows do we have here? We have 0 out of 20, so that's 0%. What's the probability of getting a blue? Well, 5 out of 20, right? Or 1 over 4. What's the probability of getting yellow or blue? Well, there's 0 yellows, and how many blues? 5, so this one's still 5 over 20. Okay. A deck of cards, right? So if you think about a deck of cards, think about a deck of cards. There's what is this? Why is it all so weird? Well, a deck of cards has your diamonds, your clubs, your queens, your hearts, and your spades, right? So there's ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king of spades, and then of hearts, and then of clubs, and then of diamonds. So there's 13 of each, okay? So going back to our question, What's the probability of getting a black card? Well, how many black cards are there? Well, first of all, the total is 52. Right, there's your clubs, there's your hearts, and there's your diamonds, and then there is your spades. Right? So this one is black, this one is black, this one is red. So there's 52, and a black card, there's 26, right? Because there's 13. So remember, there's 13, 13, 13, 13. Probability of getting black cards, 26 out of 52, or I have 7 of hearts. Well, there's only one 7 of hearts, so it's 1 out of 52. A diamond, how many diamonds? 13 out of 52. 1 over 4. Not spade, so if you don't want a spade, you want a diamond, you want a heart, and you want a club, so that would be 39 out of 52. A queen, how many queens do we have? Well, we have 1 queen of each kind, right? So it'd be 4 out of 52. Not a king? Ugh. So you don't want a king. So if you take the 4 kings out of here, well, there's 52 cards. Minus 4 kings, you have 48 out of 52. And you can divide that by 2, 24 out of 26, and divide by 2 again, 12 out of 13. And what's the probability of getting a 5 or a 6? Well, there's a 5 or 6, there's a 5 or 6 here, there's a 5 or 6 here, 5 or 6 here, 5 or 6 here. So the probability of getting a 5 or a 6, well, there's 4 5s, 4 6s, so that would be 8 out of 52. Again, you can simplify this, 4 out of 26, or 2 out of 13. 2 out of 13 chance of you getting a 5 or 6. Okay, well, this one is hopefully simple. Now the complement. Okay, when the number cube is rolled, either a 5 will be rolled or it will not. Rolling a 5 and not rolling a 5 are examples of complementary events. The complement of an event is the set of all outcomes that are not the event. Okay, so let me give you an example. Tomorrow, the chance of rain is 40%. So what's the chance of no rain? Well, the chance of no rain, well, if the chance of raining is 40%, the chance of no rain is 60%. These are complements. The probability of getting a 3 on the cube is 1 out of 6. The probability of getting not a 3 on the cube is 5 over 6. So again, these are complement. I think that's easier for you to understand. Okay. A bag contains circular chips that are the same size and weight. They're 8 purple, 4 pink, 8 white, and 2 blue. So 8 plus 4 plus 8 plus 2, there's a total of 22. The probability of drawing a pink chip, right, the probability is 2 out of 11, right, because it's, so the probability of getting a pink is, first of all, there's 4 pinks, so let me write, probability of getting a pink is 4 out of 22, which is the same thing as 2 over 11. So they're asking you, what's the probability of not getting a pink? Well, the probability of getting a pink, let me write it again, is 2 over 11. So P of not pink would be, well, obviously the complement, right? 9 over 11. See how these are complements? And when you add the complements, it will always equal to 1. Okay, so if you go back here, 1 6 plus 5 6, 6 over 6, which equals 1. 60%, 40% plus 60% is 100%, right? If you change that to a decimal, that also equals to 1. So it will always equal to 1. Okay. So you will work on these 2 problems, right? I'll give you the handouts, you can translate. But I also want you to do compound events. All right, I know I'm doing 2 things today. So probability of compound events. I go straight to it. All right, simple event. Let Let me go over here. Rolling a 5 or a 3 on a cube. So P of 5 or 3. This is a simple event because I'm only throwing the cube one time. Tossing a coin and here's your magic word, rolling a die. So I have to do 2 experiments here. Right? So this will be compound. Picking a letter from the alphabet. It's only one experiment that I'm doing. Right? So this is simple. Selecting 2 of hearts and the king of spades. So there's 2 things I have to do, 2 experiments. So this will be compound. Rolling a number greater than 3 on the dice. So how many times do I have to roll that cube? Only once. So this is simple. All right? Hopefully you understand. So there's 2 types of compound events, independent and dependent. Let's start with the easier one first. Please copy this. The probability of an event, a dependent event, can be found by multiplying the probability of the first event by the probability of the second event. I'll get to this. All right, so what's the probability that you're going to spin this one and then you're going to spin the second one? So what's the probability of getting an even number on both? So you need to do the probability of getting even, right? And if you look at your formula here, it's times. So probability of the first one, spinner, let me write the first spinner. That's called a spinner, by the way. Times, what do you want on the second spinner? You also want an even number. This is the second spinner. So on the first spinner, even numbers, 2, 4, 6. So you have 3 out of 7 chance. On the second spinner, you want the even numbers, 2, 4, 6, 8. You have 4 out of 8 chance of getting an even number. Well, you can simplify this, right? And then you can multiply, you get 3 over 14. So the probability of you getting an even number in the first and an even number in the second is 3 out of 14. So notice that this is independent. What's the probability of you throwing 3 coins in the air and then first coin gets heads, second is heads, third is heads. So P of heads times P of heads times P of heads. It's a half times a half times a half, which is 1/8. So the probability, the chance of you getting 3 coins and landing on the heads is 1/8. Sam takes a card, and here's the magic word. He returns it and then selects another card. What's the probability of getting 2 odd numbers? So I want to get an odd, right? He's going to take the card, look at it, and put it back. And that's what you have to understand about the word returns. He puts it back. And then he wants to get another odd. So what's the probability of odd numbers? 1, 3, 5, 7, 9. So the probability of getting an odd on the first one is 5 out of 10. And then the probability of getting us another odd number is 5 out of 10. Well, you can simplify this, right? The chance of this happening is 1/4. Okay. Again, sometimes you're going to see returns it. You're going to see the word returns it. Ugh, can't write. So returns or replaces, right? So one of the 2 words, which means he puts it back. So Tim selects 2 marbles. He picks one, looks at it, and puts it back, and then he takes the second one. So he wants to get a white, and then he wants to get a green. Oh, probably getting a white. Well, there's 2 whites here, so it's 2 out of 6. And then the green one, 1 out of 6. So there's a 1/18 chance. Very little chance of that happening. Okay. You have 2 cubes. One and another one here. Okay? So a red cube and a white cube. What's the probability of getting a 5 and then a 2? Well, it would be 1 out of of 6 times 1 out of 2, which is 1 out of 12. What's the probability of getting a 3 and a 3? Well, 1 out of 6 again, 1 out of 6, which is 1 out of 36. 4 and 4, 1 out of 6 times 1 out of 6, which is 136. P of 5, what's the probability of getting a 5? 1 over 6. What's the probability of getting an odd number? Well, there's 3 odd numbers, so that'd be 3 out of 6. What's the probability of getting an even number? The probability of getting an even number, well, would be 3 out of 6, right? Remember, there's 1, 2, 3, 4, 5, 6, even, 2, 4, 6. So 3 out of 6, odd, 3 out of 6. So that gives you 1 out of 4. Less than 5. Well, less than 5 would be 1, 2, 3, 4. So there's a 4 out of 6 chance to get that accomplished. And then you throw the other die, and you want to get a 6, so that'd be 1 out of 6. Simplify, you got 1 out of 9 chance. So all these are independent events. Now, probability of the dependent, so now it's a little bit different, is the product of the probability of A and the probability of B. The probability of B after A occurs. I'll show you the difference. All right. So there is 2 green, 8 red, and 5 blue cubes. So the total is 15 total. All right. So what's the probability of getting green? It is not, but the cube is not returned. So you don't put it back. So what's the probability of getting a green right now? Well, the probability of getting green right now is 2 out of 15. Yeah. And then, so you take the green marble and put it over here. So then you go in the bag. So when you go back to the bag, do you still have 2 green marbles? No. This is 1. Right, so when you go for your second green one, it is 1 out of 14. See how the total changed? So anytime the total changes at the bottom, it's it's dependent, right? Because you didn't put it back, right? Your green is here, right? It's not back in the bag. So you multiply that as 2, and you get 1 over 105. What's the probability of getting 2 blues? Well, let's change that. Probability of getting a blue. Well, the probability of getting a blue is 5 over 15, right? And then you take the blue, you take 1 blue, let's put it here in the corner, right? You go back in the bag. Do you still have 5 blue? Put this to the original number. You still have 5 blue? No, you have 4 blue. And this total changes. It becomes 14. So now there's 4 out of 14. And you guys can multiply this, or I will. Next one, let's try another one. This one is red. It says, what's the probability of getting a red followed by a green? All right. 15 total. So what's the probability of getting a red right now? The probability of getting a red right now is 8 over 15, right? The red. So you take a red marble, put it in the corner, and then there's no more red. There's 7 reds now. Now you're going for green. What's the probability of getting green? Well, the probability of getting green is 2, but how many do you have now? You don't have 15, you have 14. So that's what makes this dependent, because the second one, right, the second experiment has been affected by the first one. Okay, and that's what you have to really pay attention to. Okay, so you have cards 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So once you pick a card, you don't return it. What's the probability of getting a 5 followed by a 3? Well, what's the probability of getting number 5? Well, probably getting number 5 is 1 out of 10. So this is no longer in there. So the 5 is here in the corner. And I go back and I want to get a 3. Well, what's the probability of getting a 3? Well, there's 1 3, so it's 1 out of, well, there's not 10 anymore, but there's 9. So chances of that happening is 1 over 9. Okay, here are 6 numbers. You will pull one out and then another out without replacing the first one. So when we take it out, we don't put it back. So what's the probability of getting a 5? The probability of getting a 5 is 1 over 6. So you take the 5 out. Now you go back and you want to get a 2. Well, the probability of getting a 2 is 1. There's 1, 2 over 5. What's the probability of getting a 3 and then a 3? Well, the probability of getting a 3 is 1 over 6. Right? You put the 3 in the corner, you go back. What's the probability of getting another 3? Well, the probability of getting another 3 is 0 out of 5. So what is this? 0%, because you can't take 2 3s. What's the probability of getting a 5 and then an odd number? Well, the probability of getting a 5 is 1 out of 6. Put the 5 here in the corner, and now you want to get an odd number. How many odd numbers do you have left? Well, there's 1, 2 odd numbers, so there's 2 out of a total of 5. Okay. Next one, what's the probability of getting an even number? Well, there's 1, 2, 3 even numbers, so 3 out of 6. So let's say you got the 2 over here, and you put it here in the corner, and you go back and you want to get an odd. How many odd numbers do you have? I have the 1, the 3, and the 5. But how many do we have in total? We only have 5. So it becomes 3 out of 10. So notice that when you do the second probability, the total changes. When that happens, it's a dependent probability. 3 yellow, 4 red, 2 green. So without replacing, so we're not putting it back. She wants to pick a yellow, then a green. Right? Green. What's the probability of getting a yellow? Well, the probability of getting a yellow is 3 out of 3 out of 9 times. So if you take a yellow out and you put it over here, right? There's your yellow. Now you have 2 yellows. And then you want to take a green. Well, how many greens are there? Well, there's 2 greens, but what's your total? Your total is 2 plus 4 plus 6, which is 8. Okay? Which gives you 1 over 12. All right? Here's a number cube. So we have a cube, really every cube, right? A die. I'd rather call it a die. Here we have a die. He wants to get a 5, then a 2, then an odd number, and then an even number. 5, all right, and then a 2, and an odd, and then an even number. Is this dependent or independent? Well, what's the probability of getting a 5 here? Remember, there's 1, 2, 3, 4, 5, 6. What's the probability of getting a 5? The probability of getting a 5 is 1 over 6. Now, when I go back, is the number 5 gone? No, it's not. The cube, it's not going to change, right? But this one is independent, right? Because the first one does not affect the second one. So, what's the probability of getting a 2? 1 out of 6. What's the probability of getting an odd number, right? 1, 2, 3, 4, 5, 6. How many odd numbers? There's 3, so it's 3 out of 6. Notice that the total doesn't change. What's probably getting an even number? Well, 2, 4, 6, 3 out of 6. Right, and now you just get to multiply. What is this? 144? 1 over 144. So the chance of this happening is 1 over 44, which is a very, very small chance. All right. And I'll print some of this stuff for you.